All of the GPL data types support array variables. The rank or dimension of an array can be from 1 to 4. The number of array elements within a dimension is limited by available memory. The dim statement is used to declare an array variable. For example, here we show the creating of a two-dimensional integer array variable where we define the bounds of the array when it is declared. The first index in an array is always element 0. When you declare an array size, you are specifying the upper bound for a dimension. The number of elements for a dimension is always equal to the upper bound plus 1. We can set the value of an individual array element by including the indexes in parentheses after the name of the array. Here is another example where we create a single-dimensional array but do not specify the size of the array. Before you can use the array, you must either assign an array to it, or you must use a redim statement to allocate the elements. When array elements are allocated, numeric arrays have the value 0 and object arrays have the value nothing. Initialization of array values using an equal clause is not supported in GPL. Once an array has been declared and its dimensionality established, the redim instruction can be used to initialize or change the number of elements within any dimension. Redim can be applied to any array, so no distinction is made between dynamically sizable arrays and fixed arrays. However, redim cannot be used to change the rank of an array, and redim cannot be used to initially declare an array. Whole arrays may be assigned to each other with a single statement. When that occurs, the data is not actually copied, but a pointer to the data in the right-hand array is copied to the left-hand array variable so that both array variables access the same data. This behavior is similar to object variables. In our example, we will assign one array to another. If we modify the first array and print out the same index in the second array, we can see the modified value. When single array elements are passed as procedure arguments, they behave the same as non-array variables of the same type. Whole arrays can be passed as an argument to a procedure. In this case, the behavior is the same as when passing objects. A reference to the array is passed and any changes to the array within the method are visible to the calling procedure. All arrays are members of the built-in array class. You can use properties of this class to determine the properties of any variable array. For example, you can use getUpperBound to returns the upper bound for a particular dimension of an array. The length returns the total number of elements in the entire array, in all dimensions. Lastly, rank returns the number of dimensions in the array.